Welcome folks, I am going to introduce to you how to use LTSpice to simulate circuit problems. So I'm going to start here by loading the LTSpice. So LTSpice loaded already. LTSpice is supposed to be a very simple to use software with easier interface to simulate circuits. So the menu we have is over here. This is the main menu that you're going to have mostly. So to create a new schematic, we're going to come into this button and we're going to click on New Schematic. And then here we have some of the commonly used components that we have. This is to draw a line or a wire. This is to put a ground. This is to label a net. This is a resistor, a capacitor, inductor, a diode. If you need more components like voltage sources, current sources, transistors, and so forth, then you're going to come into this icon where it says component and you can click on it. So before I even start, I wanted to make sure that you have the grid connected to you. So if you go to view here, I'm going to click on show grid, and then I'm going to also say mark anchor and mark unconnected pins, right? So those are options, but I like to see the grid. I'm gonna also zoom out a little bit, so I'm gonna click on zoom out. I like to see the grid like that, where it is kind of zoomed out. So, and then I'm gonna come to component here. I'm gonna click on the component icon. I am interested in adding a voltage source, so I'm gonna basically type a voltage here, and the type of voltage I can use will be basically what we say is DC, AC, pulse voltage source, sine wave, piecewise linear, exponential, and the FM signal. Anyway, so I'm going to click on that, and I'm going to place the voltage source over here. And now I need to enter the DC value for it. So I am going to put the cursor on the top of the voltage source. I'm going to right click, and then it says the DC value. So I'm going to add a 10 volts for DC voltage value. It doesn't have an internal resistance, so I'm going to keep it as 10 volts like this. Now, keep in mind that the current for the voltage source going to enter is the current defined from the top. So whatever current enters into the top is the current of the voltage source. Now, I'm going to add a resistor, so I'm going to come to a resistor here. I'm going to add a resistor here, R1, but I don't want to add it this way. What I want you to know is this resistor that by default, its current is the current enters from the top. I can use this icon to rotate it 90 degrees. So by rotating it 90 degrees, this pin will become to the right, so the current will enter to the right. If I want to measure the current entering to the left, I have to rotate it by reflecting it using the mirror icon. So I'm going to delete this resistor. So I'm going to come to cut. And I'm going to click on the resistor. Now it disappeared. So I'm going to come to the resistor here. I'm going to rotate it, then flip it. Now I'm going to put it over here. And this resistor value, I'm going to make it 2K. So I'm going to come to the top of the resistor. We'll do right click, and I will enter 2K ohm resistor. And I'm going to connect this voltage source to this resistor. And then I'm going to have another resistor, and I'm going to call it R2. And R2 gonna be connected here, then R3, and R3 gonna be connected here, and then I'm gonna have R4, but R4 I need to rotate it 90 degrees, and the current will be defined to be from the right, entering from the right, so I'm gonna rotate it 90 degrees, and I will add the resistor over here. Then I will hit escape, and by hitting escape, now the resistors disappear. So I want this resistor value to be 1K, R2 to be 1K, so I will right click on it, and I will write 1K. And this resistor here gonna be 4K, so I'm gonna right click on it, and I will make it 4K. And this resistor gonna be 2K, so I'm gonna right click on it, and I will write 2K. and I'm going to connect all those resistors together. So I will have R1 will be connected to R3, and then escape, and then R1 is connected to R2, and then R3 is connected to R4, and R4 is connected to R2. Now I'm going to add two more resistors. Those resistors going to be R5 over here, and then R6 over here, and then one more resistor. I want to add it over here, but I want the current to enter the resistor from the right to the left. So I'm going to have a 90-degree shift like this, and then I will add this resistor, we call it R7 over here. So this resistor here, I'm going to right click on it, and this resistor will equal to 5K, and R6 will equal to 1K, and R7 will equal to 1K. And now I'm going to connect the rest of the circuit. Here. Now every B-Spice circuit must have a ground, a 0 volt. So the 0 volt in the lab usually is connected to the power supply. So I'm gonna add the voltage, the 0 ground to the voltage source, like I have it here. And now I completed the circuit. So there is two types of simulations I'll be interested in. The first one is what we call the operating point. So I'm gonna come to run, and run basically will say that let's run simulation, and we haven't defined any simulation yet. So I will make sure that I will use DC operating point, and by doing DC operating point, the syntax for the command is called OP, and I will say OK, and those are the values entered. Those are the nodal voltages, and those are the currents. So if we wanted to say that what's the current through R1 is that, the current through R2 is this, the current through R3 is that, the current through R4 is this, and the current through R5 is that, the current through R6 is this. Now keep in mind that the current for the voltage source will always be the current that enters the plus polarity, so it's minus the current leaving. That's why we have it negative here. Because this is a single source circuit, the current will leave the plus polarity. So the voltage of the current source will be a negative value. To print the schematic, you just go to File and Print. If you want to do Print Preview, you can do Print Preview. It will print the file. This is the preview. I'm going to close it. You can do Print Setup. If you want to do it a landscape, that will also work. You can do OK, then you can do Print Preview. We'll print the schematic for us here. I'm going to do Close. So, but this kind of operating point simulation is not good enough. So I'm going to come to Simulate here, and I would do to Edit Simulation Command, and instead of doing DC operating point, I will do Transient. That basically will plot as a function of time. Transient means time simulation. So I will say stop time. I can say that 1 second, for example, can be 1 millisecond if you want it. Start time can be 0. And then the maximum step size, I can say 0.1 milli. That's good enough. We can do OK. So you can see, I'm going to zoom in, zoom out, I'm sorry. You can see that we added the command called tran. That means it's a transient simulation. And now we have a window where this window over here will show us a graph, but there is no graphs on it, so I need to add the signals to graph. So I'm interested in the currents. So I'm going to come to Add Trace, and I'm going to select the currents I'm interested in, which is I1, IR2, IR3, IR4, IR5, and IR6. And those values should be similar to the values that obtained in the solved example that we have in another video. So I'm going to click OK. And sure enough, those are the values that we have, which are similar, the same as the operating point values. So clearly that I4, which is this one, it's around that value. So basically it does match what the values we have. If you're going to pay attention to those values, they do match the operating point values, which I'm interested in. Now you can also print this graph. Basically, you're going to do print setup here. I would do landscape, okay. And then let's do print preview. So it will show us the signals to be graphed. And then you can click on print and it will print it. So the last thing I want to talk about is the netlist. So let's look at the netlist. So I'm going to do view here, and you see LTSpice netlist. So this is the netlist, which is a file, a text file that describes the circuit. So it tells you that V1, which is this voltage, starts from node N001 to 0, and the value is 10. And then R1, which is this resistor, starts from node N001 to N002, and the value is 2K. So the description of the schematic, it is entered into this text file, and this text file is used to describe the circuit. Now this text file is the original LTSpice file, but it is good to know that whatever we describe here in the schematic is converted into netlist, and this netlist is used to simulate the circuit. It is good to know. When you run this command, basically it will simulate the circuit, which what we just showed you. So I'm going to close the netlist here, and this is a very quick LTSpice simulation that you can use to simulate the circuit example that we solved in another video. I highly recommend you to watch that video before you do the circuit simulation as well. I hope you enjoyed this video, and good luck to you. Thank you.